Question number 18a. Figure 9 shows a graph of pressure against temperature for a fixed mass of gas at constant volume. So we have the pressure on the y-axis and we have the temperature on the x-axis. So we have the graph showing the relationship between pressure and temperature. In this case, pressure is directly proportional. We can say pressure is directly proportional or is partly constant, and is partly varies with the temperature and partly constant. So that's I think we have been given that relationship. So from the graph, determine the values of N and C given that P is equals to NT plus C, where N and C are constant. So that's what I was trying to explain, that pressure is partly varies with temperature and partly constant. So that is where we are getting this relationship. And to get C, you remember you did in mathematics, which is compulsory, you did the equation of a straight line plus C. We said that M represents the gradient, that is the gradient, and C represent the y-intercept. So the same concept we are going to apply here. So we have C. If we extend this graph downwards, we will be able to see where the graph casts the pressure or the y-axis, and that will be able to give us the value of C. Then to find the value of N, N represents the gradient, so we are going to get 2 points on the straight line and be able to do that. So let's extend this graph and see where it cuts the y-axis. When you extend this graph, you can see it passes at 0. That is, this is 0 and 1. So it means that our C, which should be the value of pressure or Y, C is equals to 1. So that is how you get C, which we call in mathematics Y concept. Then we have said that N represents the gradient, so we need to get a 1 point, and then we use this one, that is 0, 1, to be able to calculate the gradient. You know how to calculate the gradient given 2 points. So let's identify another point. You can use a ruler to check 2 corresponding points of pressure and temperature. So the point I have identified is this one, where we have this is X is 4 and Y pressure is 6.5. So with these 2 points, we can get the gradient. We normally say gradient is a change in Y divided by change in X, which we take the value of Y here. This is 6.5. We minus the value of Y here, which is 1. You divide by 4 minus 0, that is a change in Y, and that should give you 5.5. You divide by 4, which should give you, you use your calculator, you get 1.375, which we can say it's approximately 1.4, and this is to 1 decimal place. So that's how you work out that question, and you'll be able to get yourself, or you would have scored. Part B, explain why it is not possible to obtain zero pressure of a gas in real life situation, and you get 2 marks. So the reason why we cannot do that is that by the time the pressure is approaching 0, the temperature will be very low, and therefore the gas most of the gas will have liquefied. So we say because by the time pressure approaches 0, this would be approaches 0, the temperature would be very low, would be very low, that's the gas we have liquefied. Liquefied. So that is the gas would have turned to liquid. So that is how you answer that question in part B. Part C, we are told a fixed mass of gas occupies 1.5 times 10 to power minus 3 meter cube at a pressure of 760 millimeter of hydrogen and a temperature of 73 kelvins. Determine the volume of the gas occupied at a temperature of 290 and pressure of 720 milligrams of hydrogen, of mercury, not hydrogen. So what to do this, we use this formula. So we know that the gas rho, Boyce rho and Charles rho, this is what we come up with when we are using the two gas rho, that P pressure 1 V1 over T1 is equals to pressure 2 V2 and T2. So what we do is that we say that 760, that is pressure, you multiply by volume 1.5 times 10 to power minus 3, you divide by 273, should be equals to 720 multiplied by V volume 2 divided by 290. So we make V the subject, we will be able to get 760 multiplied by 290, that is you cross multiply there, you multiply by 1.5 multiply by 10 to power minus 3, all this you divide by 273 multiply by 720, and here you can use your calculator and you should be able to get 1.682 multiplied by 10 to power minus 3, and this is meters cube. So that is the volume, that is the gas you occupy at that temperature and that pressure, and that's how you work out that question. Part D, we are told set any three assumptions made in kinetic theory of gases. So one of the assumptions is attraction between the molecules is negligible. So we say attraction, this is attraction between molecules is negligible. So that is one assumption. The second assumption is volume of the molecule is negligible. Volume of molecules is negligible. That is compared to the volume of the container. Compared to the volume of the container. Volume of the container occupying this is occupied by gas. The molecules undergo elastic corrosion. Undergo elastic corrosions. So that is the third assumption that we have. Another one that we have is length of the time. That is the length of the time. The length of the time. The length of the time of corrosion corrosions is negligible. I can correct that. So we say it is negligible compared to the time between collision. Compared to the time between collision, to the time between collisions. So those are the assumptions. So if you state any of the three of the four, you should be able to get 3 marks, and that brings us to the end of that question as well as the end of the paper.